Okay, video 3 for chapter 21. So we're going to be doing significance tests for comparing two groups or two proportions this time. Okay, so an observed difference between two sample proportions can reflect an actual difference in the parameters, or it may just be due to chance variation in random sampling or random assignment. Significance tests help us decide which explanation makes more sense. The null hypothesis has the general form that the difference between them is going to equal a hypothesized value. We'll restrict ourselves to situations in which the hypothesized difference is zero. So that's in other words saying that there is no difference between the two proportions. The alternative hypothesis says what kind of difference that we'll expect. That'll look similar to what we're used to, only we're looking for the difference between the two proportions to either be greater than zero, less than zero, or not equal to zero. If these can all be done if our conditions, our three conditions, are met. So our test statistic is still found the same way. There's a slight difference with it. So it's the same formula that we use for a one sample, only because it's a two sample, we'll see that our statistic is going to be found, our statistic is found by taking the difference of the two proportions. And then this is always going to be zero. So the parameter here, if you're saying that the null there is no difference, then the parameter is going to be the proportion of 1 minus the proportion of 2. Well, in your null hypothesis, you're saying that there's no difference. So then your parameter would have to be 0 here. The other thing that's significantly different is going to be the idea of our standard deviation of a statistic. It doesn't change a whole lot, and it makes more sense with your confidence intervals, but it changes a bit with your significance tests. So if the null is true, the two parameters are the same. We call their common value p, but now we need a way to estimate p so it makes sense to combine the data from the two samples. So we're going to call this pooling. So this pooled or combined sample proportion is going to be found by taking the successes in both samples and combining them, and taking the number of the total number in both samples and combining them. And so as far as our standard deviation is concerned, we're going to be using the following down here. We'll be using this to note our standard deviation. So as far as our test statistic is concerned, it is the same formula or the same form, but it looks significantly different. So your three conditions still have to be met this time because you're dealing with two samples. They have to be met by both of your populations, both of your groups. Okay, this is saying much the same. And let's run through an example and be done with this. So researchers designed a survey to compare the proportions of children who come to school without eating breakfast in two low-income elementary schools. An SRS of 80 students from School 1 found that 19 had not eaten breakfast. At School 2, an SRS of 150 students included 26 who had not eaten breakfast. More than 1,500 students attend each school. Do these data give convincing evidence of a difference in the population proportions? Carry out a significance test at the alpha 0.05 level to support your answer. So for my two hypotheses, I'm going to say that my null hypothesis is that there will be no difference between the two. And my alternative hypothesis, I'm going to say that there is a difference between the two. So I'm not going to specify greater than or less than. I'm just going to say that it's not equal to 0. I don't have any evidence of going one way or the other. I just believe that they may not be, that there may be a difference. So we're going to perform a two-sample z-test or a significance test for the difference of the proportions. So first thing I should do is check my my conditions. So it was a random sample from both schools. My large counts condition is met. So for school 1, there was 19 successes, 61 fails. For school 2, 26 successes, 124 fails. So both are at least, all of them are at least 10. And then finally, they're independent. So they tell you that there's more than 1,500 students in each school. So you know that 10% condition is met here. 80 is less than 10%, and the 150 is less than 10% of 1,500. Less than or equal to. And now we're ready to go ahead and run our significance test. So we're going to want our test statistic here. So before I even start, I'm going to get that pooled proportion. So I'm going to combine my my two samples here so I know what to put into my standard deviation. So the two successes from the schools were 19 and 26. The school 1 had a sample size of 80 and school 2 had a sample size of 150. So this is going to get me a pooled proportion of 0.1957 or a combined proportion of 0.1957. So here's my test statistic, or here's where I fill in. Remember, that's always going to be 0 for your parameter now because you're saying that there should be no difference between them. Plugging in my z test statistic will get me 1.17. At this point now, it's much the same as how your single sample significance tests were ran. So at this point, you're going to want to find your p-value. You find your p-value by using your normal distribution. So because we're saying that it's not equal to, it's a two-sided test, so you can find z either being greater than or equal to 1.17 or less than or equal to 1.17, and then we're going to multiply by 2 because that's only one tail end. We need two tail ends. So my p-value will be 0.2420. You can norm CDF that. In class, I will show you how to use the calculator. So in conclusion, our p-value is now greater than our significance level of 0.05. This is going to tell us that it's not statistically significant, so we'll fail to reject our null hypothesis. There is not sufficient evidence or strong evidence to conclude that the proportion of students at the two schools who didn't eat breakfast are different. And that's it for video 3.